You're here because you want to master alkenes with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. The next functional group, which is typically a hydrocarbon as well, is called alkenes. Alkenes are denoted by this general formula of CnH2n, and they are unsaturated hydrocarbons, which means that they have this double bond, specifically a CC double bond. These alkenes tend to be more reactive than alkanes. You need to know this reason. It is because the C double bond C is very electron rich, and it can enable alkenes to undergo addition reactions. Some of the chemical reactions of alkenes include combustion, because every organic compound can undergo combustion, so do refer to the combustion of alkanes for the same details. And you can undergo addition with these alkenes. So addition reactions, by definition, is a reaction where two or more molecules join together to form a single molecule. The molecule XY adding across the C double bond C is an example of this. And I'm going to show you how there's this adding across action across the double bond will occur. So an example of addition reaction is hydrogenation. Do take note of the reagent condition. You're adding H2 gas under 200 degrees Celsius and using nickel as a catalyst. Please memorize this. In this example, C3H6, which is propene, is going to react with H2. And how this addition will work is that the double bond will become a single bond and everything else remains the same. And with the double bond becoming a single bond, you actually have space to add the H2. So you're adding the H and another H across this double bond. Let's take a look at another example of pentyl 1,4-diene. Now, pentyl 1,4-diene is like a double alkene, meaning there's two C double bond Cs. So penta means it's 5 carbons. In the 1 and the 4th position is the double bond. Fill up the rest of the hydrogens. Now we're going to add 2 H2 molecules because there's 2 double bonds here. And the result is that the double bonds will become single bonds, with everything else staying the same, except they're adding the H2 across these 2 double bonds. So one of them here and the other one of them here. From this example, you can also see that each mole of your double bond in the alkene absorbs 1 mole of hydrogen during hydrogenation. So by looking at the number of moles of hydrogen that react with an organic compound, you can tell the number of moles of double bond from the reaction. Do take note, because this is actually commonly asked in mole concept kind of questions tied to your alkenes chapter. Another reaction that takes place that is an addition kind of reaction is bromination. So this takes place even in the dark. This is actually a very good test for unsaturation, because you can use this test to differentiate between your alkenes and your alkanes. What you're going to do is you're going to bubble gaseous alkene or shake the liquid alkene with liquid bromine in the absence of UV light or sunlight. And what you will see is that there is a rapid decolorization of red-brown bromine to give a colorless compound. Take note, you can also do the same if you use aqueous bromine as well. The main difference between liquid bromine and aqueous bromine is that aqueous bromine is orange color, but it will also turn colorless upon reaction with the alkene. So how are we going to add bromine across the double bond? Well, if you add bromine across the double bond, what you will get is a surge. For propene, everything stays the same, similar to hydrogenation. So we're going to draw, the double bond is going to become a single bond, and then because of this addition, the bromine is going to add 1 and 2 across where the double bond was. Let's take a look at an example of pentyl 1,4-diene again. For pentyl 1,4-diene, if you were to draw, this, similar to just now, we're going to add 2 moles of Br2 because there's 2 moles of double bond in this compound. And what we're going to get, I'm just going to react it downwards, is we're going to draw the same thing here. I'm going to keep everything the same except the double bonds become single bonds. And where it used to be a double bond, we're going to add a bromine, and we're going to add a bromine here. Alkenes are able to also undergo hydration reaction, where you add water across the double bond. So this is also another addition reaction. The reagent condition is important to memorize. This is using steam, 300 degrees Celsius, 60 atm, and concentrated H3PO4 as a catalyst. H3PO4 is phosphoric acid. So how do I draw the hydration of propene? Well, all you have to do, you just draw propene out. And how does the addition occur? Well, you're going to add H2O this time. And let's turn this double bond into a single bond, keeping everything else constant. And you're going to add a H and a OH. H and a OH. And that's how you actually draw your hydration of your propene. Another reaction that alkenes can undergo is addition polymerization. This is also covered under your macromolecules chapter or your polymers chapter. In addition polymerization, you only need high pressure and you can polymerize your alkenes together. For example, ethene can commonly polymerize with itself to form polyethene, which is actually used in plastic bags or films. An example of this reaction drawn is as such. First, you have ethene that you want to draw. And typically, if you see your ethene, you want to draw it such that the C double bond C is in the same line. Next, you want to look at what the question is asking you for. If they're looking for 1 repeating unit of this reaction, then it polymerizing is just you taking out the double bond. Everything stays the same, and you're just going to draw 2 lines across. This is 1 repeating unit. If the question is asking for 2 repeating units, you will draw the same thing, which is a copy and paste of 1 repeating unit, and you're going to draw it side by side. And this is 2 repeating units. Now, if they want to ask you to draw the polymer, all you have to do here is you will take the repeating unit, 1 repeating unit, and then you're going to draw a bracket across, and you're going to write the n at the bottom. So this represents that there are n number of repeating units inside this polymer. So this is if they ask you to draw the polymer. And this is how your addition polymerization works. Sometimes there are questions that ask you to determine the value of n. These are typically linked to mole concept related questions too. So do try to get exposure for those kind of questions as well. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.